let's continue. First, this picture I would like you to see the difference between two structures here. Look at the monopoly. Suppose I'm monopolist. I sell to all of you. Yeah. Let's say this is a diamond. If you want to buy this product, you have to come to buy from me. So I capture market demand curve. All consumer in this room have to come to buy this product from me. As a result, I face with the downward sloping demand curve. Suppose your willingness to pay to buy diamond is 200,000 baht per unit. I just put you guys on this demand curve here. Range from those with the highest willingness to pay downwards to here. Okay. So you can see this is a lot of consumers along this line. Yeah. Okay, if I charge the price P1, this demand curve suggests that I can sell Q. As a result, my revenue would be A plus C, this area. That's here. Initial revenue R1. Monopoly. Okay? A plus C. If I want to attract more customers, what I have to do? I have to reduce the price. Some of you, let's say, I charge, let's say, 100,000 baht per diamond. Some of you buy, some of you do not. Yeah. If I want to attract more sales, I must lower the price to attract the new customers. So I do that. I will do it. I reduce the price to P2. Once I lower the price to P2, you can see that the demand curve suggests that I can sell one more unit. Q plus 1 unit is here. Okay. So P2 times the new Q become area A plus B. That's my new revenue here, A plus B. Yeah. Okay. So I want to see what would happen to my revenue then when I reduce the price before and after. Yeah. New revenue A plus B minus the old revenue A plus C. That's leave me, this is my marginal revenue equal to B minus C. B minus C. Okay? Right? And then I modify this term a little bit. Area B, the green area here. What is the size of this area B? It's P2. Look, this area you can calculate. The width is 1. The height is P. P2 times 1. So area B you can rewrite it as P2 minus the pink area C. So this is my marginal revenue when I reduce the price from 100,000 baht to 80,000 baht, let's say. When you compare with, suppose, okay, another scenario. Now, suppose I'm sell my goods in competitive firm. So I'm a tiny seller in this market. I face with the horizontal demand curve. I must sell this good at the price that determined by the market P1. At the price P1, if I sell little Q here, if I produce and sell little Q here, my revenue equal to area A. P1 times Q, area A here. Okay. If I want to sell one more unit, is Q plus 1. You can see that if I sell Q plus 1 units, Q plus 1, my new revenue would be A plus B. A plus B. New revenue is A plus B. All revenue is A. So additional revenue I receive is just area B in this picture. What is the size of this area B? 1 times P1. 1 times P1, which is equal to P1. Okay. Here. Now you want to see what is the point of these two pictures. The main message is that if I am just a little firm in that structure, perfectly competitive market, my marginal revenue exactly equal to price. MR equal to P. in that structure. The same as the photocopy shop downstairs receive every time when the shop sell additional page, right? It gives the additional revenue exactly equal to 50 stamp. Marginal revenue equal to price. Okay. Only true in it's only true in perfectly competitive market. That's the first message. Yeah, is true only in this structure in perfectly competitive market. I make a short note in the exam. You should not do this. Yeah. Marginal revenue equal to price. Now you compare with this structure, monopoly. If I'm monopolist, take a look. When I reduce the price of diamond to P2, let's say 80,000 baht, right? At 80,000 baht. When I sell one extra diamond, I don't receive 80,000. It's not equal to price. I receive something less than 80,000. You see, P2 minus something. So that means marginal revenue in this case is less than price. MR here is less than P in monopoly structure. And we want to find the reason why marginal revenue is not equal to price, it's less than price. Alright? Okay, a lot of things to say about this picture. Before, monopolists receive A plus C. You see that. After, monopolists receive A plus B. So when area change from A plus C to A plus B, you can see that C is a loss, right? But B is a gain. C is a loss. You can say that B is a gain. Then we want to know more. What is this loss and gain? Loss? Why loss? Why loss? Because when talk about gain first. Gain. This area is gain because I sell one more diamond here. I receive P2 baht. P2 times 1. Gained due to gain due to higher sale. I can sell one more. Okay, which is good. Suppose I reduce the price of diamond. Okay, let's say first event I charge 100k. Some of you buy, some of you do not buy. Okay. Today I lower the price to 80,000 baht. Oh, the people yesterday would still buy from me, right? And new customer also interested to buy at this lower price, 80,000 baht. The problem is, I cannot charge 80,000 baht to just the new customers. This price also applies to those people who yesterday decide to buy as well. So I have to charge the new lower price to all previous unit that I can sell yesterday. Yeah. So you can see that from unit number 1 here until this queue, I have to sell at the price P2, not P1. So I lost some revenue. Why? Due to the fact that I must sell all previous units at the new lower price. Loss due to... Okay, this is important. Yeah. Loss due to all previous units sold. All previous unit. Here is a queue. Yeah, is this queue must be sold at the new lower price, which is equal to P2, not P1. So, if you were me, this is a kind of trade-off. Yeah, you gain B, but you lost C. It's a trade-off. Of course, if B is higher than C, you will have a big smile. Your revenue increase, or in other words, marginal revenue is positive. Marginal revenue is positive. But if you do this operation and it happens that loss bigger than gain, you will be sad. Okay, the message from here, monopolists, first message, if monopolists want to increase more sale, it has to reduce the price. Commonly misunderstanding from students is that, oh, I'm a monopolist, I can charge whatever price. That's not true. Even though I'm price setter, if I want to have more customer, what I have to do, lower the price to attract more quantity demand. Yeah. Second, when monopolists try to do this, it's involved with loss and gain. Second message. It involved with loss and gain. But the other structure, if I want to sell more, I just sell at the price P1. I don't need to lower the price. I have no control over the price. Okay, you should take this note here. Alright. Before I jump to this one, a lot of things to say in this picture. I will add more detail to this. Okay. Suppose you need to have 2 pages to write down this. Suppose let's consider this demand function. P equal to 12 minus Q. P equal to 12 minus Q, yeah? Let's draw this picture. Let's draw this demand curve. Here you should have no trouble when I ask you to translate this equation into the picture. It's quite straightforward. Take a look. Okay, I will make it big, yeah. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. I will be precise with the scale here, so that you can see what happens here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12. Okay. Let's draw demand curve together. Alright, P equal to 12 minus Q. Okay, what do you get from this specification? Yeah, it's 12, 12. Okay, this is a fundamental knowledge. Yeah, you will use this again in the intermediate micro EE211. Suppose you pass this. Yeah. Yeah, I want you to pass this course altogether. 12, 12, that's the specification. You can verify this. When price is 12, nobody purchase. If I charge 12, nobody purchase. If I give it for free, yeah, quantity demand is 12 units. Alright. Let's start from price 10. If I charge 10, see how many Q I can sell. I can sell 2 pieces. The demand curve suggests that. At price equal to 10, the corresponding Q, 2 units. If so, I quickly calculate my revenue. P times Q. P times Q. And I got 10 times 2. I got 20. I got 20. Then I want to increase my total revenue. Then I want to attract more customers. What I have to do, I lower the price. Let's say I reduce the price to 7. What happened is, yes, I can sell more. You can see that. So I write it down. When I lower the price to 7, the corresponding Q become 5 units. So I quickly calculate my revenue, new revenue, yeah? 7 times 5. So my revenue increased by 15. I can call this TR, new TR minus old TR. New TR is 35 minus old total revenue 20. So I enjoyed extra 15 baht from this operation. So I should be happy. Then I will denote the area to make it correspond to the picture that you observed. I have A, if you compare with the slide, this is B and this is C. So A plus C is the old revenue, 10 times 2, 20. So let's make a note here. This 20, this row 20 is area A plus area C. Okay. And then 35 coming from price of 7 times quantity of 5. So that's the area A plus B. And now you put more detail here. New revenue A plus B minus old revenue A plus C. If you work out and be abstract, 15 is actually equal to B minus C. If you do this, A plus B minus A plus C, you would see that this 15, nothing else, is gain minus loss. Gain area is B minus loss area is C. Okay. Alright, this is a loss. I use red color. And this is a gain. I use green color. If you don't have the numbers here, you can also see that, oh, B is bigger than A, B is bigger than C. So I will smile. My revenue increase. This is a revenue increase. Alright. So what next? We want to discuss more about this B and C. Let's discuss about B first. Consider B. Consider area B, which is gain. Which is gain. This gain is increase in revenue, right? Increase in revenue from what? From higher sale. Higher sale from 2 to 5, you can see this. Higher sale. I can sell more. Buy 3 units more. Higher sale. So I sell 3 more units here. At the price 7, so area B is equal to 7 times 3. What is the area then? So area B would be equal to 7 times 5 minus 2, right? 7 times 3, which is 11 baht, let's say. That's the gain in revenue. This number, this 21 baht, coming from the fact that new consumers purchase my diamond with this price, 7 baht. That's area B. Area B. Now I want you to do something with our number. What is the area B mathematically? It's not that difficult. You can see. Look at this height. This height is a P, right? It's a price 7. What is this size then? It's delta Q. It's a new quantity minus old quantity. 5 minus 2 is a Q2 minus Q1. It's delta Q. So I can write down that area B is actually price P. It's a price P. That's the height of this column times change in quantity times change in Q, which we denote as delta Q. So next slide. Okay, put this in mind. You can do it with numerical example. You can also do it with our numbers. That's the represent area B. P times delta Q. If you can do this with area B, why not area C then? Then next, consider area C, the loss. Consider area C. Area C. The meaning first is a loss in revenue. Why loss? Because the first 2 units of the good you cannot now sell at 10. You have to sell the price of 7, which is lower. So, yeah, you have to sell at 7 baht, not 10 baht. So you lost like 2 units, right? Each unit you lost 3 baht. So 2 units. This must be equal to minus 6. Okay, area C. What is this? It's a loss in revenue. Why loss? Due to the fact that the first 2 units of the goods must sell at the reduced price. Okay. By how much? Let's work with the number first. So area C equal to what? Equal to, okay, 10 minus 7. 10 minus 7 minus 10, then I put new minus O, yeah. Times what? Times 2. So minus 3 times 2 is minus 6. Minus 6. Minus 6. Alright, minus 6. Okay, now abstract form. Area C is what? What is this 7 minus 10 here? This is the delta P, right? Change in price times what? This is a Q. Yeah, the size of B is, the height is delta P, 7 minus 10. I use new minus O, yeah, new price minus O price, times the width here, 2 units. So that's minus 2, minus 6. Then I do it like this. Change in price. Change in price, which we denote by delta P, times quantity, which is Q. So area C in abstract form is delta P times Q. Okay, you got it, right? But I have a little bit problem with this. Delta P here, when I reduce the price, delta P must be negative, correct? I reduce the price. But areas must be a positive number, the area itself. I want to make area as a positive number, so I just use this trick. I just add this. So it will ensure that when I add this minus sign, when I do area B minus area C, it's like a positive area minus positive area. Then I will got the result like 21 baht minus the size of the area 21 minus 6, which equal to 15. Yeah. Okay. That's the purpose here. A little bit of trick here. Yeah. Just to ensure that area is a positive number. That's it. Simple reason. To ensure that. Otherwise, you will have something like a B minus C, like a 21 minus 6. That's not true. Ensure that the calculated area is a positive number. Okay, simple reason. That's it. Okay, you got it already? Now, recall that change in total revenue is B minus C. We got that. The revenue that like a 21 baht minus 6 baht 15. We derived that before, yeah. Change in total revenue is a gain minus loss. Now let's do this. Then I would get, what is area B? P times delta Q minus, okay, minus already you see, minus here, then I will move this term to here, minus this. I make the area become positive number, yeah. Don't forget this, just bring the whole thing here, including minus sign, to be represent area C here. Okay. Alright, B minus C. Work out on this. P times delta Q now become this. Okay. That's the change in total revenue. If you put the number, you still get 15 baht, yeah? This is a 7 times 3, 21. This is a 3 baht less times minus 3. Look at this equation, is true. Now, when you do this, I reduce the price, so delta P is minus 3. Minus 3 times 2, that's minus 6. You see? 21 minus 6, yeah. 15 baht. Yeah. This equation is great. We want to have MR. What we have to do? Divide it throughout with delta Q, right? If you want to have MR, MR is change in total revenue when you change your output. So you have the top term already, and if you divide it by delta Q, you got MR. P times delta Q plus, just bring it down. That's the top term. Divided by delta Q. Now we got MR already. Now you want to make it look nice. P plus. Okay, that's MR. You got so far so good. You got this expression. So MR consists of two parts, yeah. You got MR here. Let's manipulate this term a little bit. So dig out your own memory about elasticity. Elasticity of price elastic demand. Percentage change in Q over percentage change in P. That's the recipe for elasticity. Top term is, okay, I make it possible to digest for you. Percent change in Q can be calculated by this formula. Change in Q over Q. This, when you divide it by Q, this is the Q that you depart from is OQ, O quantity. That's percent change in Q. Percent change in P. Delta P divided by the price that you depart from. That's P1, not P2 when you put it. Okay. Now you cross 100 out and you rearrange this term. What do you get? Yeah. Change in Q over change in P times P over Q. Keep this in mind. Now we will utilize this. You see that this term elasticity look quite similar to this second term on the right here. Yeah, quite similar. So what I want to do, let's do this. Yeah, copy down MR again. Let's do this. Let's multiply this term by P over P. Nothing changed, and you just try to play with this term. Just like multiply by 1. Okay, what do you get then? P plus let's rearrange a little bit. Yeah, delta Q over delta P times Q over P times P. I just rearrange this a little bit. What do you see here? Look alike or not? I mean this term and this term. Look alike? Yes or no? Not exactly. Not exactly. When you have elasticity and you twist it, you got this one, right? Upside down. This one, put it down, this one, put it up. You got this, right? So, how to call this one? 1 over elasticity. So, P plus, yeah. Okay? Utilize this term, you got this. Okay. Finally, let's rearrange a little bit. Now we successfully link MR with price elasticity of demand. So this is difficult to look at this term. Or I put it like this. Because you know that this elasticity is a negative number. If you don't want to deal with negative number, you can use this trick. Just put absolute term here and put minus sign here. Okay. 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 This is quite important to the monopolist. He knows that his extra revenue will be plus or by minus, depends on this elasticity. So when he lower the price, his revenue will increase or decrease. That's MR. Depend very much on consumer price sensitiveness. That's the message here. Okay. Okay, for young economists like you, your job is to interpret mathematical language into the verbal language. So here it said marginal revenue is inversely related with price elasticity of demand. Okay. How? Let's try to put, if, let's say, if this equal to 1, or, okay, it's your choice, yeah. You can use my version or this one, yeah. It's the same thing, yeah. If elasticity equal to 1, if you put 1 here, what is MR then? Equal to 0. Then marginal revenue is equal to 0. Okay. Next, if you put something bigger than 1, let's say bigger than 1, then okay, if you put 10 here, would MR be negative or positive? 10. Negative or positive? Positive, yeah. If you put 10 here, this term will be very small because it's divided by something big. So 1 minus something less than it must be positive. So MR is positive. This is what monopolists like, yeah. What I want to do when I lower the price, I expect that my marginal revenue would be positive, not negative. So I found this something like this already, that then if I reduce the price, I must do it when consumers are very sensitive to the price change. I must do it here. Then my marginal revenue will be positive. That's the advice. Third, if you put something less than 1. Okay, look at this recipe. It's quite easy. You put 0.2, 0.3, 0.4, 0.5, 0.7, 0.8 less than 1. It will make MR negative. MR is negative. Oh, now I get some warning already. I'm a monopolist. When I lower the price, I will not do it when elasticity is less than 1. When consumers are less sensitive to the price, it's not worthwhile to lower the price. My marginal revenue will become negative. The meaning here, I remind you again, this is chapter 4. Yeah. What is the meaning of this? Demand is inelastic. Yeah. This is a mathematical language. Verbal language. Demand is inelastic. What does it mean? If price change by 1%, if price change by 10%, you guys will change your purchase by less than 10%, let's say 2%. That means you are price insensitive. Price reduced by 10%, but your purchase increased only by slightly, 2%. So that means you are not so keen about this price reduction. You are price insensitive. But the meaning of this, greater than 1, demand is what? Elastic. Percentage change in Q is bigger than percentage change in P. So if I reduce price by 10%, you guys will buy more than 10%. Percentage change in Q, let's say 30%, 40%, 50%. That means you are price sensitive consumers. Alright, that's the link between marginal revenue and elasticity of demand. So that's why entrepreneur must know something about this elasticity, because it will affect on the additional revenue when you do a price reduction. So let's go to look at this picture. Okay, the demand function for the blue line here, you see 24 here. Now you should be very comfortable to do this. When you see this blue line, you can convert this line to be an equation 24. So this demand curve is coming from this P equal to 24 minus Q. Okay, talking about blue line first. This is a demand function. Okay, you see the blue line, the purple line here. It's called MR, marginal revenue. Marginal revenue. To have marginal revenue curve, you must have TR first. Think backward. If you want to have MR, equation for MR, you must know TR first. Where is TR? It's not here yet. Let's get it out here. What is TR? TR is P times Q. What is a P? Yeah, up here. 24 minus Q times Q. We got TR equation already. Okay, now when you see TR, you see MR. That's easy. Just differentiate TR with respect to Q. That's a solution for you to get marginal revenue. This is MR. dTR by dQ, yes, give you 24 minus 2Q. Alright? Compare with this demand curve. Same intercept Y, 24. Yes, 24 is the intercept Y exists. But slope of MR curve would be twice steeper than demand curve, which is 2 here. This blue line cut here at 24. So if you want to draw its corresponding MR, you just make a halfway and draw it. You got MR curve. Okay. You know this from look at this slope. 2 times of the slope of demand curve. There is minus 1. Minus is just downward sloping. Okay? You got MR curve already. The mathematics that we looked previously just spell out in this picture. When demand is elastic, absolute E is greater than 1. If you go back to read your lecture note, you just wrote, marginal revenue will be positive. You see this purple line is above negative zone. This is positive. When you plug in 1 into that equation, I'm talking about this equation here. MR equal to P1 minus 1 over ED. When you plug in 1 in absolute term into this, it will produce 0 MR. So MR cut here. MR equal to 0. And lower portion of this is a place that demand is inelastic. Which means that absolute E here is less than 1. When you put 0.2, 0.3, 0.4, 0.5 until 0.9 into this, or 0.99 into this, it will give you negative MR. It's dived to the negative zone already. Yeah, it's dived down already. You see, positive, 0, and then negative is related with elasticity. That's why when monopolist reduce price, he will just finish doing it at this. he will not try to lower the price in this region. If the price is here, yeah, if he reduce the price, his revenue is positive, marginal revenue positive, marginal revenue positive, so on and so forth. Yeah. He will not do further than this point. Yeah. If he reduce the price more than this, yeah, that's the disaster. So what I want to say, monopolists. We want to lower the price. What is the purpose for this? Lower the price to raise his revenue. To raise his revenue. Only when I give you this condition, when what? When demand is price elastic. Okay. Here we're talking about this over this range. Yeah. Okay. Okay, that's the main message from this picture. Secondary message. When you have demand function, you should be able to derive its corresponding MR function. That's the process. It just shown here. It's just like a cooking book. Step 1, find TR. Step 2, differentiate TR with respect to Q, and you got what you want, MR function. And you got function, you can plot the purple curve comfortably by looking at the slope here, MR. So in the exam, when you do this curve, yeah, please do not do something like this, yeah. Like for example, this is a demand curve, and when you draw MR, you draw like this. It's illogical. Yeah. Okay. As I told you, slope of MR must be twice as steep as the demand curve. If this is 10, this must cut at 5. If this is 12, this must cut at 6. That's my message. Be careful here. This knowledge you use until you are 4th year. When you draw this demand curve and corresponding MR. I said corresponding, that means the shape of this curve originates from the shape of demand curve. That's the word corresponding. It corresponds to this. The shape is like this, it cut like this because of demand curve look like this. Okay. Okay. Relationship between marginal revenue and price elastic demand has been explained. Take a look at this table. You will get better understanding here, the numbers here. Take a look. Let's look at this line as a reference first. Yeah. This place is at the midpoint of demand curve, which MR cut at the horizontal axis at 0. You can see that. That's the midpoint of the demand curve. Up here is the upper portion of demand curve where demand is what? Elastic. Okay, this table is just not in the absolute term. It's a real price elastic demand. Okay, I can do this. Absolute E is greater than 1, so that's the elastic region. Observe this. When I lower the price, my marginal revenue is positive. You can see that. That's my incentive to do this. I get more money when I lower the price. Loss effects of gain is better than effect of is always effects of loss. So my marginal revenue is positive. I will not be stupid to lower the price when demand is inelastic. You can see from this column who will do this. Reduce the price and marginal revenue is negative. Here, in absolute term, it's less than 1. Yeah, you just put absolute term and it's here, less than 1. In elastic region, yeah. Okay, it's confirmed by the picture, by the table here. Okay. Oh, before I move to this one, I switch back a little bit to this. I want you to see this. Okay. Look at this. You are sleepy. Okay, from when I sell at 10 baht, I got 20 baht, right? And if I lower the price to 7, I can sell more, and my revenue is 35. What is a change in revenue? Change in total revenue? Change in TR equal to 15. It's here. 15. Change in TR. What is an MR? Equal to what? If TR equal to 15. MR equal to equal to you said 0 from 5. Yeah. This is your TR, right? You divided by delta Q. What is delta Q? 3. It's 5 then. So this picture said I get 3 more units sold. When 3 more units sold, my additional revenue is 15 baht. So that means each unit that I sold here give me additional of 5. It's 5, 5 and 5. Yeah. So then my revenue increased by 15. Okay. This 15 is change in total revenue. Don't make a mistake. You don't call this MR. It's just change in total revenue. If you want to find MR, just divide it by delta Q. So MR is equal to 5. Okay. All right. Please keep your lecture note until EE211. You will see this again. If you want to give to your junior, you will have to ask them to make a photocopy. It's your asset until the 4th year. Okay. Now, my question is, I want to maximize profits from what I sell, what I produce and sell. Question is, how many diamonds I should produce to maximize profits? Just go back to this equation. Okay, I want to find a Q that maximize profits. So I start with my profit function. Profits pi is the difference between revenue and cost. R is revenue, C is the cost. Yeah. So I have to select Q that max my pi. So this is a profit maximization problem again. I write down this again. You can observe that when we talk about monopoly, you always see the big Q. This is a market. I deal with everyone here, my potential customer. TR, my revenue depends on Q, yes. My cost also depends on how much I produce. Every time when you write whatever mathematical language here, you just have to speak it out in your mind. Revenue depends on quantity that you produce. Cost also depends on amount that you produce. So, mathematical economics, you have to study next semester maybe, EE211. When we put the word Q underneath the word max, it's tell the audience that, this decision maker, me, I'm a decision maker here, a monopolist, I must make decision on Q. So things under the word max will tell people that, oh, this is his guy, this is his choice variable. He must make a decision on this. He must select Q that fulfill this job, maximize profits. Okay. So again, go back to FOC. First order condition suggests you just have to differentiate profit function with respect to Q. Let's do it. Differentiate profit function with respect to Q. If you are not happy with D, you can put baby version is delta, the same. Differentiate profit function, this function, throughout with Q. When you talk to your friends, this is called d pi by dq, dtr by dq, dtc by dq. Differentiate profit with another language. Differentiate profit with respect to WRT, with respect to Q. And set it equal to 0. Yes, we discussed about this. Yeah? We want to find the peak of the mountain. That's why this condition said at the peak of profit curve, slope equal to 0, d pi by dq, something like this. This is pi, this is q. The q that makes your pi must be the q where when you measure slope of this mountain, it must be equal to 0. That's the logic. TR is MR, quite easy. TC by DQ is MC, equal to 0. So you got this. MR equal to MC. This is a profit maximizing condition, which state here, highlight this. It's a profit maximizing condition. If I want to make a profit by selling diamond, the quantity that I should produce should follow this rule. I should select the Q where marginal revenue equal to marginal cost. That's the profit maximizing condition, or profit maximizing rule, or golden rule of profit maximization. Then let's do it. We have the guideline already. This is a rule. So let's take a look. I have 15 minutes left for this picture. Alright. Okay. This is quite easy because you don't need to draw it. But let's start from what we don't have. What if this picture is blank? If this picture is blank, let's start from drawing demand curve. The blue line here. The light blue line here. Demand curve first. And when you have demand curve, you think of, oh, marginal revenue curve, corresponding one. Just draw the one that corresponds to this one, twice steep as demand curve. Okay, you got two lines already. Think about this, yeah. Once you put demand and MR curve into this picture, now step 2, you introduce cost structure of this firm of me. So I put my cost structure. This is my average cost when I produce. Unit cost fall first, reach the bottom, and then after some certain point, certain Q, my unit cost is going up. That's look like a valley. That's AC. And then marginal cost curve, cut at the bottom of the valley here. MC, please make it correct in the exam. Yeah, cut at the bottom of AC. Okay, now you got 4 curves already. Okay. Win. Which Q I should produce, can you suggest? Which quantity of diamond I should produce? A lot here.
Q2.
Q2. Why? Why Q2? You mean this one? Why Q2?
Catching to the point that MC intersect AC.
MC is here. MC intersect AC.
MC.
Again, please. What intersect what?
MC intersect AC.
MC intersect this point. Okay. Do you agree? Yes. No? Why? Let's talk to him to change his mind. Why you disagree? Why Q star then? Because I put star then you choose it? We recall this rule. The place that maximize profits is the place that the Q that it must be the Q that such that marginal revenue equal to marginal cost. You have marginal revenue and marginal cost curve here. Marginal revenue and marginal cost intersect here. That means the height of the two curves equal at this place. You can measure the height of marginal cost curve, the height of marginal revenue curve, the same. If this is a 10 baht, this is a 10 baht. So, MR equal to MC here at Q star. So, it's a profit maximizing Q. Here is MR equal to MC. Which not right now, you should see it already. So you call this profit maximizing Q or profit maximizing output level. Okay, I produce and sell at Q star. How much I should charge you for this diamond? I go to the demand curve. I will charge you this price according to the demand curve. Is this price P star? So I got my price and output already. Yeah, I answered my question already. How much I should produce? Q star. How much I should charge to the customers? P star. Okay, and my profit will be maximized. You don't see it here. Why profit is maximized? You will see it in the other picture. But let's discuss first here. The message for this picture is that if I produce less than this or more than this, it's not a good idea. I will tell you why. Okay, let's talk about if I just stop producing at Q1 first. I don't continue my production until Q star. What would happen to my profits? If I stop producing at Q1, what's wrong with this? You see something wrong? Yeah, look. Okay, listen this carefully. Okay, you have now you experience how to look at this kind of thing already. Suppose, okay, this is a 100 unit, yeah. If I want to produce unit 101, next to this Q1 is 101. This next unit here, 101 here. I want to know if I produce this, how much I would get from my customer. Oh, here. That's marginal revenue. So, I will get this, let's say, 20. If I produce this unit and I sell to someone, I get extra revenue equal to 20 baht. Should I produce this? I must compare with what is the additional cost of producing this, right? You go to up here. Marginal cost is here. You just go to the right and to the left. Let's say 8 baht. Should I produce this unit? Should I? Yes. You will do it the same like I did. Additional revenue 20 baht. Additional cost 8 baht. If you produce and sell this unit, you get 12 baht as a profit, correct? So, but if I stop here, I will not get this 12 baht. Right? So, the same argument follow. Unit 102, 103, 105, 104, 110. If you don't produce this unit, you lost this stick. I lost this already. Lost this, lost. So, if I stop at Q1, I will not enjoy these profits, this yellow area here, which composed of this stick. You just add them up together, it's become loss in profits, right? Unit 101, I lost 12 baht already. Unit 102, maybe 11, 10, 9, 8, 7, until this. So, it's clear that if I stop at Q1, I will not get this yellow area, which represent profits from this unit that I should produce and sell and get it. Okay, you see that? Lost profit, look at this wording. Lost profits from producing too little. Too little means little compared to what you should do. Q1. And charge high price, this price and output combination doesn't work. It's make you lost profits here. So, produce too little, charge too high price. This is not a good idea in this. Okay? Now, how about Q2? If I produce too much and charge too little, if I produce Q2, demand curve suggests given Q2, the price should be P2. Produce too much and sell too low price, too low compared to P star. It's not a good idea. Why? Can you explain something like I just said? Yeah. If I produce Q2, what would happen? Yes.
You will produce too much.
Yes, I produce too much. What's wrong with that? What's wrong with that? Should I produce this unit Q2? Let's say this unit, unit number 200. Should I produce this unit? No, because look at this picture.
You cannot receive more than
You lost. I will lose more than I get, right?
yes.
Look, if I produce this unit, my cost, my marginal cost is this until this. Here. What is my revenue from selling this unit? Just only this little. So, I would be quite insane to produce this unit. Marginal cost is super high like this compared to marginal revenue. Why should I? Yeah. If I don't produce this unit, I will save this loss. Yeah. It's true for this unit too. Yeah. If I go back to Q, I will resume my loss. Yeah. If I go back to Q star, I will not lose this amount of negative. Yeah. Yeah. So this is lost profit when I produce too much. Okay. All right. That's why this is an equilibrium. No incentive to deviate. Once I'm here, I don't have incentive to produce less than Q star or more than Q star. Yeah, because I will suffer from loss. Alright? Okay, that's it for today.